Alright, in this video we're going to take a look at 5.7, the Chapter 5 review, and we're going to work on and look at a couple of different problem types that occur here. So if you're having trouble with this review, I'll go through and do all kinds of the different problems. I'll give you an example of each of these. So the first one we'll do is question 1 here, and question 1 we're converting between percent, decimal, and fraction. And so I'll do a couple of these. Let's start with this first one here. We're going to take 5/8 and we're going to turn that now into a decimal and a percent. Well, if you notice the fraction 5/8, that's also a division problem, 5 divided by 8. So to turn fraction into decimal, all I got to do is get my calculator and do that division. So I'm going to take 5 divided by 8, which is going to give me 0.625 as a decimal. Now I want to take that decimal and turn it into a percent. Well, percent means out of 100, so I'm actually going to take this decimal now and move it 2 places to the right. 1, 2, so that's going to be 62.5%. The percent always looks bigger. Notice it here at 62.5, the decimal equivalent, meaning this is equal to that, is 0.625. The reason this is because percent means out of 100, meaning we're taking this 62.5 and dividing it by 100, and if we divide it by 100, we're going to move the decimal 2 places to the left to get the decimal equivalent. So percent always looks bigger than the decimal. Alright, let's take a look at this next one now. 0.82, taking this decimal number and turning it into both a percent and a fraction. Let's start with the percent. Well, same thing we did before. We're going to take this decimal and move it 2 to the right. Percent always looks bigger. So that's going to be 82%. Now, if we take 0.82, and if I say it that way, it's going to be hard to change this into a fraction, but if we actually read what this decimal number is, it will tell us the fraction automatically. So notice this is 8/10 and 2/100. So the way we would say this all together is 82/100. Well, 82/100 is a fraction. And now all I have to do is simplify that 82/100. Well, they're both even numbers, so the first thing I would do is I'll cut these things in half. So I cut 81 in half, divide it by 2, it'll give me 41. And if I cut 100 in half, it'll give me 50. And now I'll check and see if I can simplify that anymore. There's no common factors in 41 and 50, so that's the best I can do. Alright, so you would just kind of follow those instructions to complete the rest of that table. Next problem we're going to take a look at is problem 4. Problem 4. What percent of 80 is 12.4? Well, this is a percent base amount problem, a PBA problem. All we have to do is put the information here correctly into that formula, and we'll get our answer here. So what percent? We don't know what the percent is, so that percent up there is going to stay P. So I guess the first thing I would do is I would write this. P times B equals A, and we'll just fill that stuff in here. So percent we don't know. Percent of 80. Now notice that we're always taking a percent of the base. So notice we're taking a percent of 80 here, so 80 is my base. That's how you know which one, because sometimes you get confused. Is the 12.4 going to go here or here? Is the 80 going to go here or here? That's the confusing part. The way you sort that out is we're always taking a percent of the base. So 80 is our base here. So P times 80 is going to equal then 12.4. And now all I have to do is solve this problem. So I divide both sides by 80. And I'm going to get a decimal number here. So I go ahead and do that division. 12.4 divided by 80 gives me 0.155. So this is what I got when I put that into my calculator. I want to turn that now into percent by moving the decimal 2 places to the right. Remember, percent always looks bigger. So it's going to be 15.5%. Alright, next question we're taking a look at is question 7. And again, this is another percent times base equals amount. So I just need to fill that in. This time I know the percent. So 126%. When I put that into my equation, however, I'm going to want to write that as a decimal. So notice here's where my decimal would be in percent, and I would go 1, 2. So that as a decimal number, that's 1.26. Let's see if I know the base. Remember, I'm always taking a percent of the base. I'm taking 126% of, I don't know. So that thing that I don't know is my base. So times B, and then is going to be 90. So now I want to solve this guy. So I'm going to divide both sides by 1.26. And B is 71.42. I'll round that to 71.43 since it was this. This is what I got on my calculator, 71.428. You can round this to any place value you want here, just as long as you round it accurately. You could give me an answer 71, 71.4, or 71.43. I'll go with 0.43 for my answer there. All right. Next, we're going to look at question 9. A golf shop pays its wholesaler $40 on for a certain club, and then sells it to the golfer for $75. What is the markup rate here? Or in other words, what is the percent change? So we're looking here for percent increase or percent decrease. The formula is going to be given, but this is what it is. The percent increase or decrease is always the change over the original. Okay? So let's take a look here. Change over the original. So I want to figure out what the change was. Well, if I started at $40 and I go to 75, that's a change of $35. Okay? So there's my change. Now I want to go back to the original. The original was the starting value, which in this case was 40. So I have 35 over 40. I'm going to do that division. 35 divided by 40. It's going to give me a decimal answer, 0.875. So as a percent, that is 87.5%. And now this is an increase. So I want to make sure that I indicate or communicate that. Oops. That this was a percent increase. You always want to make sure you include that whenever you're doing a percent increase or decrease, because we won't know. If you just said 87.5%, we wouldn't know whether it's an increase or decrease. So you want to make sure you communicate that piece. All right, next question we're taking a look at is 10. After taking his girlfriend out to dinner, Oswald decides to leave a 15% tip on the bill. If the bill is $38, how much should the tip be? So now we're not asked for the total bill, we're just asking for the tip here. So this is a PBA question, percent times base equals amount. The percent we're looking for is 15%, so I'm going to write that as a decimal, 0.15. What am I taking a percent of? Well, I'm taking 15% of the bill. What was the bill? Bill is $38. So remember, we're always taking a percent of the base, so 0.15 times 38 is then going to tell me what the tip should be. So I'm taking 38 times 0.15, and it looks like the tip should be $5.70. All right, next question we're going to take a look at is question 14. Question 14, Ernie made 54 out of 80 free throws. What percent did he miss? Notice this is what he made, but we're asking for what did he miss. Well, if he made 54 out of 80, how many did he miss? Well, let's figure that out. So I'll take 80 minus 54. It looks like he missed 26. So we want to turn that into a percent. So what we're going to do is this is a PBA question, P times B equals A. We're looking for the percent here. That's our unknown. We're taking a percent, some percent of 80, and then we're going to end up with this 26 free throws missed. So we're going to look like this. Percent times 80 in the end is equal to 26, which is the number of free throws he missed. So now we want to solve this for P. So I'm going to divide both sides by 80. And if I take 26 divided by 80, gives me 0.325. Now I want to turn that 0.325 into a percent. So that's 32.5%. And then let's also, since it's a story problem here, we'll put that on there, that he missed. 32.5% missed. All right. Next one we're looking at is question 16. During 1 year, the value of a diamond increased 30%. If the diamond was originally $4,200, what is it worth 1 year later? So I think this is a great time to use a growth factor here. So if it increases 30%, that means our growth factor is going to be 1.3. Let me show you how I got that. Well, no change to the value of the diamond would be 100%. It would retain 100% of its value if there was no change at all. But this thing is going to increase 30%. So I'm starting with 100%, adding 30% to it, which gives me 130% of the overall value. And as a decimal number, that is 1.3. So that's how I got that growth factor. To find out the new value of this diamond, all I got to do is take 4,200 and multiply it times 1.3. And that will tell me what the new value is. So I'm taking 4,200 times 1.3, my growth factor, and it tells me now that the diamond is worth $5,460. Okay, next thing we're looking at is question 18. I'll just do a couple of these for you now. So 18, fill in the chart. Remember that always start with 100%. And we add or subtract to get the growth or decay factor. Okay? And these are kind of the key thinkings here. 100% minus our percent decrease will give us our decay factor. Start with 100%, add the percent increase to get our growth factor. So let's start with one of these decay factors here. If I decrease by 25%, what I'm going to do is I'm going to take 100%, minus my percent decrease, which was 25, which would leave me with a decay factor of 75%, and as a decimal, 0.75. We never write these as percents, the decay or growth factor. We always write them as a decimal because that's what we're going to use to calculate here. All right, let's take a look now maybe at this one right here. This is kind of tricky. If we have an increase of 0.03%, well, let's think about that. I'll kind of come up here to think about this. I'll say, all right, well, I'm going to start with 100%. And I'm going to add to it the increase, which is a tiny little bit, 0.03%. So that's going to give me 100.03%. Now I want to take this percent and turn it into a growth factor. To do that, I'm moving this decimal 2 places to the left, 1, 2. So it's going to be 1 point, and there's going to be some zeros here, 3 of them, in fact, 0, 0, 3. That would be my growth factor. Okay, let's take a look at one more here. This one's kind of tricky. I think once we get this one, we'll have the whole thing figured out. So we're starting with now an increase of 150%. So again, let's come over here and show you what I'm thinking. Well, no change would be 100%, but then I'm going to increase that by 150%, which is going to be 250%. Now I want to write that as a decimal because that will be my growth factor here. So I'm taking this decimal and moving it 2 places to the left. So my growth factor here is 2.5. All right. Let's take a look now at question 27. Question 27. Your car that you purchased 2 years ago for $21,500 has decreased in value by 35%. We want to use a decay factor here to determine the worth. So if it decreases by 35%, well, we're going to start with 100%, take that 35% away, which will give me 65%. Now, as a decay factor, I want to take that and write it as a decimal. So that's 0.65. The reason is because I go from percent to decimal, I move it 2 to the left. So here's my decay factor, 0.65. I want to just take the original value, 21,500, and multiply it now by this 0.65, and it will tell me what the car is worth now today. So 21,500 times 0.65 will give me the car's value today, which is $13,975. Alright, next question we're looking at is 29. Oh, it looks like there's quite a few pieces to this. I'll scroll down a little bit more. Okay. 29. A small cup of coffee typically has 200 milligrams of caffeine in it. In general, 40% of the caffeine in your system is eliminated every 4 hours. So what that means, after 4 hours, we've lost 40% of the caffeine. What would be the decay factor to determine the amount of medicine still in your system 4 hours later? Well, after 4 hours, we've lost 40%. If we've lost 40%, what percent remains? Well, that's 60% remains. So my decay factor here is going to be based on 60%. And the way I do that, look, just very simply, same thing I did last time. Start with no change, which is 100%. Decrease it by 40. That equals 60%. So there is my percent remaining. As a decay factor, take the decimal, move it 2 places to the left. My decay factor is 0.6 then. So let's see, what would be the decay factor? That's question A, 0.6. Okay, let's look at part B. A person drinks 2 small cups of coffee within a short 2 small cups of coffee, short period in the morning. Fill in the chart. So if they drink 2, looks like we got a typo here, because look, small cup of coffee is 200 milligrams. If we drink 2 small cups, that would be 400 milligrams here, not 800. So let's say this person has not had 2 small cups. They either had 2 big cups or 4 small cups. But this is a typo that I'll have to fix in the future. But let's say we started with 800 milligrams, and we want to know how much is left. Well, at the end of 4 hours, 60% will remain, or our multiplying by our decay factor of 0.6. So we're going to take 800 times 0.6. So at the end of 4 hours, we would have 480, and this is milligrams, so we want to communicate that. Now at the end of 8 hours, we are going to multiply by 0.6 again, so we'll take this 480 times 0.6. Oops. Multiply that again, times 0.6. That'll give me 288 milligrams, and to fill in the rest of the chart, we would just proceed as normal. Every time after 4 hours, multiplying by 0.6, by 0.6, by 0.6 to get the next value in the table. Question 32. And this may not line up exactly with your question 32 in your book, but this is the problem that I think we need to take a look at, this compound interest. Okay, so for compound interest, we are going to use, let's scroll up just a little bit here. For compound interest, we're using this. The reason I know this is compound interest, because it tells me right here, if it's compounded monthly, as soon as you see something being compounded in any period of time, we know that we have to use the compound interest formula. All right, so let's enter this stuff in here. So there's the formula that I'm going to use right there, and I want to enter that stuff in. This is the amount after the period of time, so we don't know what that is, so that's going to be A. P is the principal, the original investment, and we were originally investing $12,000. 1 plus, okay, R up here is the interest rate. So let's go back in the problem here and figure out the interest rate. Interest rate right there, 3%. So I want to write that as a decimal though. So I'll move the decimal point 2 places, 1, 2. So that's actually going to be 0.03 as a decimal. N is the number of times it gets compounded. Well, this thing is getting compounded monthly, and our interest rate is APR, which means annual or yearly. So if it's getting compounded every month, how many times would it get compounded in a year? How many times it get compounded in a year? That's 12. So I'm going to put a 12 down here. All right, and then up here, N again is the same thing. That's 12. And then time is, in this case, since this is our rate is based on years, our time is going to be based on years. Ooh, 5 months. That's tricky, 5 months. That changes the problem quite a bit. Notice this was a yearly interest rate. Everything is set up for a year here, and our length of time is 5 months. Well, there's 2 ways to do this. You can do 5 months. Well, what part of a year is that then? It's not going to be 1 full year. It's only going to be part of a year. The part of a year that would represent would be 5 over 12. So you could take set the formula up like this, and notice this multiplication is going to work real nice here, because you can see the 12, the common factor of 12, dividing right out there. Think of this, come over here on the side to think of this. I'm going to take 12, I'll write it 12 over 1, times 5 twelfths. Well, heck, those 12ths are going to divide out nicely and leave me with an answer of just 5 there. So really my exponent there is going to be 5. So I'll put a little arrow there. That's equal to 5. And honestly, no matter what kind of numbers we get here, we got to figure out what this answer is first before we can start punching this stuff in our calculator. Okay? So I know this exponent is supposed to be 5. Now I'm ready to go ahead and calculate this. So first thing I'm going to do is I'm going to take and do this division, 0.03 divided by 12. Then I'll add the 1 to it to get an answer inside the parentheses. Once I have an answer in the parentheses, I'm going to take it to the 5th power. Once I take it to the 5th power, I'll get that answer and multiply it by the 12,000. So here I go. I'm taking the 0.03 divided by 12, leaving that answer right in my calculator now. I don't want to round anything here. And then I'm going to plus 1 equals. Now I've got that answer. Now I want to take that answer to the 5th power. And you've got two options there. On your calculator, you're going to have a button that looks like this, a little hat. That means take it to this power. Or you'll have this, x to the y, which means take whatever value you got to some power. My calculator has the x to the y button. So I'll hit the x to the y button. And then I want to hit that to the 5th power, since that's what we figured out what that exponent was. And I'm going to hit equals again. Then I'm going to take that answer that's in my calculator. I don't want to round this yet. I want to take exactly what's in my calculator and multiply that times 12,000. If we round along the way here, we'll get an answer that's different. In fact, significantly different. Especially if this exponent, the larger this exponent is, the bigger of a difference we'll get if we round. So we don't want to round until we get to the end. So it looks like my amount here is going to be 12,150.75, and that's money. So I'm going to put a dollar sign on that. Okay, those are the problems I wanted to show you in section 5.7. If you have any other questions, you feel free to email me, and I'll try to get those answered for you as well. All right, thanks. Have a great day.